How about you?
I'm good. I'm good. I'm going on vacation tomorrow for 2 days. Happy about that.
Anyway,
You, I do not see you. I do not see your
Oh,
face.
wait, yeah, probably not.
your photo only.
Alright.
It's good. It's good.
Right. Now it's good to see you.
Alright. Yeah. Good to see you guys.
Okay. So, is it okay to start?
Yes, please. And Yair's here. Is Yair here? Can I get him?
Not
Yeah.
yet. I think not yet. Yeah, you should be here.
Do you, it's up to you guys. I don't know what your time schedule is. Mine is limited, but not, I'm not gonna end the call this early, so. So,
I
you
think
want me to?
Yair, yeah, we better start after Yair is coming.
You want me to send him a text or something?
Okay, we will start with our test report for the points. Question by Yair Mail last May. Okay. Okay, can you see this?
Yes, I can.
Okay. 계속 하라고.
제가
줄줄이 읽을 필요 없어요. 안 넘어가.
Yeah, first of all, we got the report. Yeah, we got the first report from Mr. Yair.
No, it's from me. But-
Yeah. Yeah. Right. It is about the WK060, and the problem was the runout issue,
Yes.
and so we requested you to send the samples to us. So we tested the five samples after we got them, and the results, as you know, we already sent our test results like this.
Anyway, already informed to you, we are controlling the runout characteristics, control limit by 3 micron at 3D. And according to our test result for the samples sent by you, at the 3D, I think it is acceptable. 2D is acceptable, but there is no data. But at the 1D, it deviated from our control limit much. Anyway,
You changed that because you had a 1D on the.
yeah, 1D, yeah, as I said to you, yeah. At the 1D, the deviation is much.
Brandon, you can't change the test report when you send stuff up. You can't have a conversation if you're changing the test report.
Okay. Anyway, we agree that at the 1D there is a 15 microns deviation or something like that. We agree. Okay, go ahead.
And we got the three requests from Mr. Yair Bruce. And the first one is the outthread square to back face. Actually, we discussed this issue with the R&D team and the quality control team, and they say it cannot be measured in a threaded state. So we measured the sample without thread machining, and the result was the 4 micron.
Which means that we do not machine the thread without tapping operation, only with the guide hole, right? Only with the guide hole, we check the squareness of the back face and got the result. It is around 4 micron something.
Okay.
Yeah.
And the first issue, the second one, the R-thread square to back face, back face to taper. We measured a runout of back face to taper instead of threads. So I checked the misalignment of the taper and back face. The squareness of the back face is checked by the height deviation, the deviation of the back face to taper. The result is the you can see the table.
So the spec is around 50 micron. The spec is from NC. 어디 있는 거예요? According to ISO standard, the spec is 50.05 mm.
Yeah.
And the measured result is much less than that control limit. So it is acceptable. It is within acceptable range.
The second request, the R-thread square to taper. It is also cannot be measured in a threaded state. So we measured the sample without thread working also.
Okay.
A concentricity of taper to threaded boring section. Actually, it is this is items other than drawings and specs specifications. Anyway, the result was the 0.0076 mm deviation.
7.6 micron around here.
Right. I believe you.
The second request was the east flange square to taper. So square between taper and flange, scale of taper concentricity and flange face. The flange face is not the contact surface. So
Right. So Simon, you can save yourself because it's not a dual contact holder. It plays no role in it at all. So,
Yeah. Anyway,
Okay.
anyway, we measured. Yeah.
Yeah, thank you for checking. It plays no role. So. But thank you for checking.
Okay, here is the summary of our measurement. According to the points highlighted by on Mr. Yari's mail, and overall, we think that there is no significant deviation from the spec. So, in conclusion, we are in an opinion that the machining condition of the of our chuck has not does not have the significant problem. There is no evidence of the deviation according to our measurement. So I think that the outline, meaning outline of our chuck is within spec. There is no problem. Even drilling of the hole has no problem with it.
I believe you. But Simon, may I speak for just a moment? Okay, all of those things that Mr. Brewis and the other person talked to you about play no role in the problem. They of course do not have anything to do with the problem at all. All the work you did does not have any role in the effect of the tool. First of all, the way the tool is held in to the machine through the retention knob is held with fingers like this, okay? And it pulls back in. So you realize how out of square the retention knob would have to be to affect it? It's always going to pull in. So I believe you're making quality, the back end of your tools, I've had checked many times. The back end of the tools are very good quality. I've never, ever had one complaint at all. And I've had machine tool builders that check the Big Plus so that they can make sure our dual contact is as good as the Big Plus, actual Big Kaiser Big Plus. And that's fine. So I do not believe for a moment that anything that you just checked had anything to do with the runout we currently face. Nothing at all.
Anyway,
everything we face as trouble is on the front side of the tool, not on the back side of the tool. Everything's on the front side of the tool.
Anyway, we are also in an opinion that even if there is no significant dimensional deviation on the outline or boring of our chuck, the condition might be changed after assembling to the machine spindle, because after assembling of the retention knob and by assembling to the spindle, there must be some pressure because the retention knob should be pulled out after assembling to the machine spindle. So the condition should be different when we check the condition without assembling of the retention knob. But regretfully, there is no way to check the machine spindle assembly condition because there is no machine with the CAT spindle.
Right. Simon, can I speak again? The way you check your runout, I think is acceptable. I think it's a bad idea to check it in a machine tool. You do not know how many times a machine was crashed. You do not know how many times the machine doesn't have a poor quality spindle. You have to check runout in a quality gauge in a lab.
Yeah.
Okay, so all of the things that were suggested were just wasting your time, and I wish that we could have conversed on that before you spent the time. The problem is is I'd like to show you again, if it lets me do it. Do you see my screen now?
No.
No.
Oh, well, that's okay.
Your calculation?
I'm trying to share my screen. Can you see anything?
Yes.
Okay, do you remember this slide? Right? And we remember that the problem is the front of the tool, not the back of the tool, the front of the tool. This bore is going at a severe angle. That's what's happening. This bore is at a severe angle. That is the only thing that can cause the type of runout that you have. The only. And so, however you're manufacturing, whether it's in process, whether there's a non-robust where you don't maintain the center line throughout the honing process, or whatever it might be, that's what the problem is. The problem is on the front of the tool, not the back. We don't need to spend any more time on the back side of the tool. It's the front of the tool. So if we have not looked at this portion of it, we have not even started to look at the problem yet. Because remember, it's not about the tool, it's about the cutting tool. It's not about the tool holder, it's about the cutting tool. And if the cutting tool is not sitting in this bore straight, it will never be acceptable, ever. You can say it's at 3 microns at 3 times E all you want, and we will never sell another tool. Because the tool must be straight and maintain center line throughout the entire process. And yes, there will be deviation as it gets 4, 5, 6 times D. Everyone understands that. I think that 3 times D is a fine qualifying spot to check it, but it has to be straight. You have to have total indicator runout, not just runout in a spot, which means it has to maintain that throughout the entire bore.
Anyway, we have no objection to your opinion. It should be straight. So in case we control the runout condition at the 3D, by 3 micron, even at the 1D or 2D, it should be less than 3 micron at least.
Yes.
And we also agree that, but the actual measurement at 1D, our chart has a problem. Yeah, we understand. So we are trying to find the real assignable cause of this problem, and also looking for the way to solve this deviation. But as already informed to you, until now we have failed to find the perfect solution about this deviation.
So this means that every single tool I have on my shelf, thousands of them are suspects to not being manufactured properly. Thousands of hydraulic holders are suspects.
But anyway, regarding our control
No,
limits,
you gotta answer the question, because if you're not clear on your robust process for manufacturing, you're telling me that every single holder I have on my shelf is suspect to being this type of situation that I'm showing on my screen and sharing with you.
but Bill, so far we've controlled the wrong characteristics of our hardware shop by 3 micron and 3D for a long time. In spite of that, there has been no significant problem during customers' use. Of course, at the special.
I've not heard much of a problem right now. However, right now, as Mr. Brooks will tell you, we are getting into much more sophisticated end users that check better.
Understand,
And they do
understand.
not allow for this. And so now I have another tool today that I accepted return on for runout. Now it's on a hydraulic power E-hydro. And so this is not good. This is not good at all. Our power E-hydro is the future of our hydraulics. And if we cannot trust that, we will not be able to sell it.
Bill, 1 second, please.
Yes, go ahead.
Simon, good morning. How are you?
Hello, yeah, how are you? You're late.
Good morning. How are you?
Yeah, fine.
Simon, and I have an idea. Just think about it. We have competitors, am I right? We have Shark, we have Lindex, we have Hymer, I don't know, but every hydraulic company in the world.
Mm.
Do you have competitors holders? Do you keep some competitor holders?
Yeah, basically, I have no disagreement about your opinion. Yeah, but the actual is not. That is the point.
Raymond, it's a question. Do you have competitors in YG1? And I'm sure there is competitors hydraulic holders. Maybe the R&D has it, maybe someone has competitor holders, hydraulic holders similar to us, that we can check and see what is the tolerances of that. And if no, I recommend you to buy some competitor holders and then evaluate the internal holes of them and see what is the difference between us and them. This is the way that you're going to learn, because just to evaluate what we have, it will take you years to evaluate.
Mm-hmm.
I really recommend you to buy some competitors if we don't have, and look and evaluate the runout of the competitors. And then if the runout is good, then open and evaluate the tool himself inside and learn how they do that without runout.
Anyway, according to investigation results so far, you know, in case of the hydraulic shop, the structure, the construction is somewhat different from the other two holder, you know.
I understand.
Yeah, it is cramped by hydraulic oil around the tool. But according to the results of the investigation so far, this kind of problem may happen by the irregularity of the inner diameter after cramping. We think that must be the point.
Okay, so how do you solve it, Simon?
Yeah. As already said to you, regretfully, so far, we have failed to find the perfect solution about this matter.
Okay.
So we are checking every process in the production, because the production process of this hydraulic is somewhat complicated compared with the others. In the construction, at the inside, we have to insert the sleeve, and it is welded by brazing to the whole body. And after that, we fill the inside by hydraulic oil. And during the
I'm not an expert, but I would like to know how the shunt works, because I was there when they inspected the shunt. And shunt is in 1D, 3 to 4 microns in 1D. And that's the reason we lost the business. I would like to know how the shunt holders is using it. Is it a totally different system? Why they do not have this problem and we have this problem.
Yeah, understand. Just before you already informed to us that in case of the Shanghai direction, there is no problem, even at the 1D, 2D or 3D, always same. But ours does not. So it is our problem. We understand our problem,
Are
current
you
problem.
familiar with the system of Shank or not?
Mm-hmm.
Are you familiar with the system that Chunk is doing? Is it similar to ours or not? I'm not expert in tool holders. But my ambience cannot work in their tool holder if it doesn't work. So we need to understand what is the problem, and sometimes we look at competitors and look what they do and maybe change it.
Anyway, we've checked the. Actually, we have some hardware check at our side, at our hand. So of course we've checked their chart, but so far there is no how can I say meaningful difference between ours and Shun. Only on.
You expect to be the Shank and they have 15 micron like ours?
No. I'm not talking about the run out measurement. I'm just talking about how can I say construction or structure.
Okay.
Yeah, of the chart. We agree that in case of the Shunk, there is the Ronald measurement is uniform, different from ours. We agree. But why there is a difference on Ronald measurement between ours and the Shunk? Even at the moment, we have not found out the exact reason. That is the point. So we are checking every process one by one, but it is taking more time than expected.
Simon, I want you to understand something. YG1 7, 8, 9 years ago,
Mhm.
you don't go to the customer that they're going today.
Mm,
Today we're getting to customers with very high tolerances,
mm,
and I am fighting with getting end mills
mm.
that will run this 30,000 RPM or 25,000 RPM
Yeah.
in high accuracy. Without the tool holders, they will not work. And I don't want to tell them that SSK cannot make.
Yeah.
You need to understand.
Understand.
I understand that we're very upset, and he's right 100%,
Mm,
because he's the product manager. But without the tool holders, I cannot run tools.
mm.
You need to understand that it's not something, and Mr. Song is pushing all the time to get to these high performance and big customers. And as you know, we have problems. It's not the first problem. I know that you had problems before. So it's ruining the name of YG1, not only SSK. And I understand that you tell me that you didn't have problems in the past. This is a customer of at least 12 years with YG1. This is the first time that he's testing tool holders.
Mm.
And he's 4G, he's using V7 Plus, he's using Titanox, he's using drill Linox, he's using taps, he's using everything. So suddenly, it's not about only the tool holder, it's about the name of YG1.
Understand.
Because we
Understand.
friends, the first time we friends with this customer.
Mm.
And I saw the list, if you can, who is having the PowerPoint? You, Bill, or they?
Yeah, that's mine, that's mine. Yeah,
Can
you're,
you move to page 14, please? This is the Rust, the not Rust.
yeah.
So the Rust, we claim, and I believe in, that it came with Rust.
I took that one off ourselves.
We didn't inspect it. We should inspect the tools when we get it inside the company. So the Rust came directly with that. So it's not something that happened at the customer or in our warehouse. That's another thing that was written here, Rust, and I asked Bill, and Bill said that this Rust was, it came from the customer like that. So again, Simon, we're looking and these tools are high performing tools. It's not a ER collet, it's an hydraulic.
Mhm.
Hydraulic is not good. We're looking for high performance to use our high performance. And the main reason we are doing this meeting is not only by this specific case.
Mm.
We're getting more and more, and we're pushing hydraulic, and Mr. Youngtech team is in this meeting, and he's manager of all the America, and he's pushing to sell a lot. Without quality,
Uh-huh.
and Simon, this is the first time I'm getting involved in tool holders. But
Mm.
Youngtech not, I'm pushing everybody on angles.
Yeah.
And it's developing all the time.
Mm.
So we are trying to be number one in the world, we need a food solution. And part of the food solution is this orders.
Anyway, we are also very afraid of the it may ruin the reputation of the YG1, and it may cause a kind of the adverse effect to cutting tool bridges. We are worrying about that point too. So though until now we haven't found out the perfect solution about this problem, as we are making every effort to find a solution about this problem, I think that we'll be able to find out some solution in near future. But as I said to you, it takes more time than expected. So yeah. So please be a little bit more patient. I'm quite sure that we'll find a solution finally.
Okay?
Because we do agree that this kind of thing is not favorable to the on the viewpoint of the use of the customer. We agree.
Simon, how long it will take?
It is hard to say at the moment, but
It doesn't help me a lot. I need to know how long, this problem is sitting on, it was sitting on our desk for a month and a half, but now it's sitting on your desk for what, 3 weeks? At least 2.5, 3 weeks. So we need to know what is going on.
yeah, we have to see. But as I said to you, we are making every effort to find a solution as early as possible. And regarding this matter, we will keep you posted on our progress of our investigation and our action. Yeah.
Okay, Simon, so what I want, and I'm not the expert, Bill is the expert, I'd like to know what you guys are doing, or what you did up to now, summarize to us. How do you evaluate that? And then what is the plan to do next? Yantek, you're very quiet. Do you agree with me on that?
Okay, yeah.
Yes, I agree. Yes, we need a second
It's okay to tell us
so
that
we can fix.
we're trying, but if you tell us what you're doing, with the state you're doing, and Bill can look at that and tell me, or tell us, this is the right way to go, this is not the right way to go. He's an
Okay.
expert here, but I want you to share what you're doing, because 3 weeks doesn't make sense if you didn't do nothing.
Okay, I will share our plan, our schedule to find a corrective action against this problem.
Okay. It's not only
Once we have this conference call, well, we will share our plan.
What you did up to now and what you plan to do. Okay?
Okay. I agree that. Yeah.
Please.
I understand.
Maybe we can help. Simon, maybe Bill will look at that and we'll say, okay, try that. You have to start trusting us because we do have experience, not in manufacture, but we do have experience with tool orders.
Okay.
Okay? Please share with us so it will give us a little bit more confidence that you're doing the right things. We need to work as a team, not only SSK working on that, and we are looking and pushing.
Okay.
Okay?
Yeah. Of course, our plan or our schedule might be changed according to the situation. But anyway, I will share our schedule, our idea with you. Yeah.
Yes, please. And I know that, Yantek need to report to our chairman what is going on because he's involved on that too.
Yeah.
So, and I don't want to push. I can push, and I don't want to push because I like to talk with you guys before I push.
Without your push, even if you do not push us much, we are doing our best.
Yes.
Yeah.
Simon, listen, our YG1 regional sales manager is pretty new for us, but he's very, very aggressive and he's getting us a lot of opportunity. When he saw that, he told me, I'm not going to sell any hydraulic holders until we fix that. And then actually he has another problem. I think Bill, the one that you returned is in too. Am I right? It's Bill, with Jeff? Bill?
They didn't give me that one back yet, but I have
Okay,
another
we
one.
know that there's a problem with Jeff too.
Yeah, well, We don't know that yet because he hasn't even replied to us to set the
Yes, yes.
He's
But
not
it is-
seeing it. He's not seeing it. But yes, I have another tool.
There's another complaint.
Yeah.
And he didn't know about that. Jeff didn't know nothing about this stuff. So, but again, Simon, we really wanted to take it serious.
Mhm.
I would stop if I didn't think that it's a
Mhm.
serious problem.
Mm.
Okay?
Okay. Anyway, Bill, as I said to you, we will share our plan with you
Obviously,
yeah.
it's what I will be copying, but it's going to build, not to be. I'm not the expert.
Yeah.
I can help on investigate because I have ideas what to do, but I am not the expert into routers.
Of course, during our progress to find a solution, if there is any need of your help or need your support or need your advice, I will let you know. Because so far, anyway, it seems to be very hard than expected, according to the current situation.
The most important thing, Simon, is update us. Don't give us 2 weeks and we need to send a reminder, I need to send a reminder. Update us every 2-3 days. Yes, we did that, it didn't work. Yes, we tried that, it's working. Let's try that. But don't leave us like that for 2 weeks without talking with us. Because we need to solve this problem, because if it's a major problem, like Bill said, we will have a big problem. So we need to figure, first of all, what is the problem here, and maybe it's a very quick solution later, if we have a
Okay.
problem. Okay?
Okay.
Thank you very much.
Okay, sorry for running into trouble on this matter, but we will find a way.
No need to be sorry, we just need to solve. Everybody, we know it's like you want, we apologize and apologize.
Of course, we are in the same boat.
Yes, we need to solve it and move on. We don't
Okay.
have time, seriously.
Okay.
Our target on sales is much higher than we're getting, and we don't need problems with quality.
Mhm.
You understand that?
Okay, we will keep you posted on this critical matter. Okay?
Thank you. Thank
Okay.
you, young man.
Simon, by the way.
Uh-uh.
By the way, Simon.
Oh, yeah,
By the
Bill.
way, ER16 collets, we checked over 150 collets,
Mm-hmm.
and we have 30% failure.
As I said to you, the control limit is from 15 to 20 micron at 3D, according to you, is different from ID. But you mean that it off from those criteria?
30% of our tools are much worse than that.
Let me have details by mail, okay?
Yeah, we're gonna put it together, but I'm just telling you that we're checking them, and I just got returned, almost 70 collets from an end user. He said he doesn't want to be returned them.
Okay, let me have details.
All of them.
Any, I'm not, I don't know why there is a difference between yours and ours, but once I received your complaint of the ER16 collet, I've checked the stock, some pieces of the stock. Check the measurement, but
The ones I'm talking about, many of them have burrs. The slots are not in the center of the bore. There's a lot of different things. There's big burrs, there's a big taper within the ER collet bore itself. So you're checking metric, I'm checking inch. And
okay, Bill, I understand your problem on ER collet too. So let me have more details and your checking result by mail. Then I will review and I will check our stock once again and come back to you.
right,
Okay?
I'm just explaining that we have to take runout much more seriously.
Why? Why always learn at every place? ER collet or hardware check or what?
Well, and also, what did we talk about? Last thing is where was that? Oh, I sent it at a different time. No, not that one. Yeah, you didn't get any response back with the collet craft nuts.
Yeah, you are talking about the crack.
Yeah, that's.
Year
well,
11.
That's different, that's from last week.
Anyway,
And,
we already, as far as I know, we request you to send some samples. 보내달라고 하면 그랬어요. Yeah. So you know, in case of the nuts, it's not manufactured in house, but we already informed that thing to the supplier. But anyway, let me have the actual samples of the cracked nut. So it needs investigation, detailed investigation.
Simon, how is the inspection of this stuff? Are you buying it from a supplier and you never inspect that? You just ship it?
Of course, once we receive the parts from outside supplier, we are performing incoming inspection according to the sampling plan first.
Every item? For every item?
Mm-hmm.
For every item, or you just do a sample inspection?
For instance, ear lot, of course, ear color, of course, we are performing incoming inspection. Push start bolt, yeah, also, yeah.
Simon, so if you do inspection, how do you explain all the problem the bill has?
Pardon?
If you're doing a full inspection, how do you explain all the problem the bill has now? With the ER16?
Simon, it's not a full inspection, it's a.
Sampling inspection, yeah.
Sampling inspection according to our HUL, the system. So maybe if anything happens, much more than our, the runout accuracy, then we have to make the sampling, ratio much more. Or even at the moment, we should do the full inspection.
Yes, because of the problem. If we have some problem like that, you're right, Mr. Lee, we have to inspect everything. And Bill claimed that the hole is not in the center and it's debearing that this is a visual.
Yeah, there's a visual problem with many of them.
Yes, so there's something that definitely needs to be inspected much more in detail.
Mm-hmm. Anyway, regarding the problem of the parts, please let me have the samples in question so that I could discuss with the supplier. As Mr. Lee said to you, in case of parts supplied by outside supplier, we are performing sample inspection, and if does not meet the acceptance criterion by sampling base, we are returning whole to the supplier. But anyway, we have to check.
Okay. Okay, very good. We will wait for an email from you, Simon. So
Okay,
you give us an update what you pick up to now and what's the plan. And try
Okay.
to update us in 3-4 days, because we will know what's going on.
Okay, I'll do that.
And I recommend you to take a shunt tool if you have and just measure it.
Yeah, I know that. We already checked that. Okay,
Okay.
thank you for your recommendation.
Thank you very much, guys. Thank you, Mr. Reid, for helping us.
And the bill already request to you, please send us samples of the in question of the colored or lot. Okay?
Right, we're gathering all the details, we'll have it by next week, early next week.
Okay. Thank you.
I just received them back from the end user today, so I need to grab some of those and check those.
Okay, I'll wait. Okay?
Waiting for the end user ballots to be returned.
Okay, thank you for joining this call, conference call, and I will keep you posted on this matter. Okay?
Thank you.
Okay, thank you.
Bye.
Thank you. Bye bye.
Have a good day.
Yeah. Actually, playing one.